Students, we will continue with our lectures. So today we will discuss the structure of learning. So let's first look at the ingredients of ML. What are we exactly trying to do? So we have to extract certain features to be able to create a model out of them to perform the right set of tasks. So how do we select the features? I have briefly discussed this in the last lecture and we will have a full lecture based on this. Then to design the model, we need to first train the model. So for training, there are various kinds of learnings that we have. So I will discuss them right now. So what are the types of learning that we have? We have supervised learning, we have unsupervised learning, we have semi-supervised learning, and we have reinforcement learning. So let's go through them one by one. So in supervised learning, I will just concentrate on the supervised learning right now. Data scientists provide input, output, and feedback to build a model. So there are typical examples of linear regression, SVMs, that is support vector machines, and decision trees, which fall under the supervised learning. So looking at it in detail, now in supervised learning, we have the input variables and we have the output variable given to us. So like I discussed a few examples earlier, we have x1, x2 till xn features available with us and we have y. So maybe we are trying to predict here it could be rainfall. So we are trying to predict the rainfall based on certain environmental parameters that we have, the humidity, the temperature, wind speed, whatever parameters that I have. Based on those, I am trying to predict a rainfall. Now this is going to be a numeric value. And then I could also have another category of supervised learning wherein I am trying to predict the class. So I am trying to classify. So I could have an email as a spam or a ham. So that's a classification problem where I have two classes defined. I want to find out the class. And here also I have labels attached to the data that I am training on. So you have to remember that labels are available when we are doing supervised learning. And the values are given wherever my supervised learning is happening. So typically we train the data through a learning algorithm. We make a model and then we test the data like I told previously for the desired accuracy, and we keep iterating till our desired accuracy is reached. So there are two kinds of supervised learning. We have regression and we have classification. So regression is when I have a numeric value and I am trying to predict that value. So it could be the cost of a house based on certain parameters. It could be maybe my amount of loan that I can get sanctioned. That's again a number. I could predict the rainfall. Anywhere where I have a numerical field associated with my output, it's a regression problem. And classification is when I have labels and I have output classes specified. So spam, ham, then yes, no, maybe I want to go out to play, yes or no, it's a classification problem. I could have more classes. I could be like, say there's a certain problem of image recognition. In image recognition, we are trying to recognize the face based on the classes that I have. So maybe I have trained my model for 10 faces, then I try to classify into those 10 people that I have, and 11th could be an unknown variable. So in supervised learning, the data set on which the machine is trained consists of labeled data, or simply said consists both the input parameters as well as the required output. So like I said, there are two categories here, classification and regression. Classification is that involves predicting a class label, and regression is when I have a numerical label. And there are various algorithms which fall into this kind of learning. So you have linear regression where I try to model in a simple terms of a line equation. I try to find out the output. I will discuss all these algorithms as we move further in the class. Right now you can just understand that linear regression, logistic regression, k-nearest neighbor classification, SVM, decision trees, random forest, and Navy Bayes theorem, they all fall into the supervised learning where either I have a numerical label given to me or a class label given to me with my output. So another way of looking at this supervised learning is that you are basically making a more intelligent machine learning algorithm which is learning from experience. So generally your Gmail is able to recognize the spam emails, but whenever you get an email which it is not able to recognize, it asks you to categorize that email as a spam or a ham. So based on that new experience, it is now then further able to classify all those kind of mails again as spam or ham. So it is an intelligent system which keeps learning. And it learns a target function that can be used to predict the values of a discrete class attribute. So whenever a new data set comes in, I get a new email. If it falls in the same category as the previous one, either it's a spam or a ham according to whatever label exists now for that new model. So similarly, I could have categories like approve, not approve for a loan, high risk, low risk again for a loan. So the task is commonly called as supervised learning, classification or inductive learning because we are inducing this learning. So this brings us to the end of this class. I will continue in the next one. Thank you.